Hey everyone, we're going to go ahead and take a look at radical functions, specifically at the square root functions and the cubic root functions. So we're going to start off with square roots. So when we say radical, a radical function is a function in the form f of x equals the nth root of x. The square root function is a type of radical function. For us, it's actually the most simplified version of a radical function because we don't even show the type of root we're taking. So the parent function is f of x equals the square root of x. So if we're going to go ahead and graph this, we can get some points. So we get 0, 0, 1, 1, 2, 4, 2, and 9, 3. Again, notice those are perfect squares and they're square roots. And then we're going to go ahead and draw a graph. This should be a review because I do know earlier in the year we did parent functions. So from here we can see our domain. It starts at 0 and goes to infinity, as does our range. Do make sure that we're putting a bracket with the 0, not a parenthesis, to make sure that we're saying that we're including 0. We do have something called an endpoint. Sometimes you might also see this word as a starting point, which is going to be where the graph starts or ends, depending on how you want to phrase it. So in this case, I think it more of a starting point because I usually think start to finish, left to right. So our endpoint or starting point is at 0, 0. And our end behavior is a little bit different from what we've been doing, mainly because there is no negative infinity for our x values. The lowest x value we actually have, or the most left x value we have, is going to be 0. So what do the y values go as the x values go towards 0? And they also go towards 0, which is our endpoint or starting point. And then as we go to the right forever, which would be infinity, like we have done previously, the graph also goes to infinity. So square root functions also only have one type of interval. They're either increasing or decreasing depending on your transformations. But for the parent function, it is always increasing, meaning from the beginning to the end, it is going up and forever. So 0 to infinity is increasing and not applicable for decreasing. And as always, pause the video if you need time to finish copying down anything. So continuing our review, we have transformations, which again, we've gone over several times this year. But just as a review, that h is always our horizontal shift. If I see a plus h, we go left. If I see a minus h, we go right. K is going to be our vertical shift, meaning if I see a plus k value, we go up. If I see a minus k value, we go down. And as I told you, in every function, h comma k tells us something important, and in this case,
those found inside without supervision will face disciplinary consequences, such as school suspension.
In this case, it tells us our endpoint or starting point. And again, if a is negative, it is reflected across the x-axis. If the absolute value, meaning ignoring the negative sign, if the absolute value of a is greater than 1, it is a vertical stretch. If the absolute value of a is between 0 and 1, it is a compression. So go ahead and describe the transformations of each function compared to the parent function. So again, we've left our transformations at the top, or the formula in the top for where we would find AHK. So let's go ahead and take a look at number 1 together. Actually, we're going to do number 2 together. So looking at number 2, I can see that I have an A value and I have a K value, mainly because the K value is definitely outside the radical sign. So since A4 is going to be greater than 1, so we have a vertical stretch by a factor of 4. And the minus 1, which is K, means we go down by 1. So based on that, I do want you to go ahead and do the other 3 problems. So go ahead, pause the video, give it a shot. All right, let's go ahead and check your work. So looking at number 1 here, I have an H and a K. So the H tells me it goes right 7. And the K tells me it goes up 2. On number 3, we do have a negative A. So that tells me I have a vertical reflection over the x-axis. we have a k value, so plus 3 means to go left 3. On 4, I have an AHK, so we have A, H, and K. So A is 1/2. 1/2 is less than 1. So we're going to have a vertical compression by a factor of 1/2. We have -2, which means to go right 2. And then we have -6, which means to go down 6. Go ahead and check your work. Again, as always, pause if needed. Number 5 is asking us to write the equation given the transformation. So I want you guys to go ahead and try this, and then we'll come back and talk about it. All right, so here's number 5. The square root parent function is reflected across the x-axis. So reflected across x-axis tells me -a. Then the shifted left 7 units, so that tells me my h. And down 1 unit down for my k value. Write an equation that represents this situation, or this represents this function. So it doesn't say anything else other than a -a value, so that means I just need a negative sign in the front. So we're going to go ahead, square root -x, and since it's going to the left, we're going to do +7, and then -1. Do make sure that when we're writing our equation, that you are leaving a space here, that this radical is not including the 1. If it includes the 1, it actually changes our answer. So do make sure that we can clearly see that the radical stops before we write our -1. Next, we're going to go ahead and graph in each function and identify key characteristics. So let's take a look at number 7, and then you guys will go ahead and try the other problems. So on number 7, I have h equals 1, k equals -4. So that tells me 1, -4 is my starting point, ending point, however you'd like to phrase it, over 1, down 4, 1, 2, 3, 4. Now there's a couple ways to go ahead and fill out the rest. You can either use a calculator to get your table, you can go ahead and figure it out yourself. But this is where, in class specifically, I've made a really big deal about knowing your perfect squares. If you know your perfect squares, you can graph square roots. So the distance you move to the right or left, in this case, we're going to be moving right, I would take the square root of that number, and that would tell me my y value. So if I move over 1, the square root of 1 is 1, so I go up 1. My next perfect square is 4, so I'm going to go over 4, 1, 2, 3, 4. And the square root of 4 is 2, so I'm going to go up 2, 1, 2. My next square root is 9, so I would move over to the 9th away from the starting point. Square root of 9 is 3, so I would go up 3 from here. 1, 2, 3. And I can draw my graph that way. So that is one way we can actually graph it without a calculator. Fairly doable, especially if you know your perfect squares and the square roots of those perfect squares. If not, again, you can use a calculator, but knowing those numbers does help you at least pick the right numbers to look at on the table. But moving on, so we already have our endpoint based on h comma k, 1, -4. For our domain, you can think of your domain, it's going to involve h in some way. So 90% of the time, or 95% of the time, it's going to be bracket h comma infinity. So in this case, h is 1. And 50-50% of the time, depends if you have -a or not, it's going to be bracket k comma infinity. About half the time. So in this case, k is -4. The one that would change the most is actually going to be your range, more because we'll have the reflections for the -a values. My end behavior, your leftmost point for x is 1, so the lowest point for my y, or what happens at -1 is y is -4. I can see it's going up and to the right, so infinity, infinity. And it is always increasing from start to finish. All right, taking a look at numbers, actually, I want you to go ahead and pause the video, try number 6. If you have the actual physical handout, I want you to go ahead and do the other two problems as well, 6, 7, 6, 8, and 9. All right, let's go ahead and check your work. So for 6, h is 0, k is 5. So 0, 5 would be my endpoint. Since a is positive, I can actually go ahead and say this is 0 to 5, or I'm sorry, not 0 to 5, 0 to infinity. My range is 5 to infinity. So as x goes to 0, y approaches 5, infinity, infinity. It is always increasing. So those are things, behind the fact that a is positive 1, there's nothing in the front. A equals positive 1. I can fill out most of this part and then do my graph. So go up 5, 1, 2, 3, 1, 2, 3, 4, 5. Over 1, up 1. From my vertex over 4, up 2. From my vertex over right 9, up 3. So my graph looks like this. Taking a look at 8 and 9. So on 8, again, if you have a packet, go ahead, we continue because you're supposed to try these. If you do not have the handout, go ahead and try these and then go ahead and check your work. So on 8, A is 3. H is -1, K is 0, so I know I have -1, 0 as my endpoint. So I know as x approaches 1, y approaches 0. So this one's a little different more because we do have a different a value. So the a value just means to multiply how much I would go up by 3. So I go over 1, up 1 times 3. 1 times 3 is 3, so I actually go up to the third. Go over 4. I'm supposed to go up 2, but 2 times 3 is 6. So I'm going to go up 6 instead. I go over 9, up 3, but I'm supposed to multiply that by 3, so I get 9. So that is what my graph looks like. I can see we're going up and to the right forever. It is always increasing. And A for decreasing. My domain, -1 to infinity. My range, 0 to infinity. Number 9, I have A is -1, H is 2, K is 3. So 2, 3. So as x approaches 2, y goes to 3. So since my a value, I'm just going to multiply what I would go up by my a value. So when I go over 1 to the right, I would go up 1, but 1 times -1 is actually -1, so I'm going to go down. So in this case, we just have a reflected value. So instead of going up, I'm actually just going to head down. So I'm going to move 4 over. I'm going to go down 2. And if I could, I would go over 9, but I can't. 6, 7, 8, 9 would be about right here. So it's going to look like this. So my domain is still going to be 2 to infinity. My range, though, is going to change, and that's going to be -infinity because it is going down. And it's going to go, the highest point is going to be 3. My range, as x goes to the right, my graph goes down. It is never increasing. It is actually always decreasing. Right, moving on. So we're actually now going to move on to cube roots. So cube roots are very similar in kind of just almost everything we do except for the shape. Cubic is another type of radical. It's the next one up. It's how we would undo cubes. So the parent function is the cubic root of x. So I would plot my points. So the cubic root of 0 is 0. The cubic root of 1 is 1. Cubic root of -1 is -1. And then we have 2 cubed, which is 8. So the cubic root of 8 is 2. So that's how we get our points. It makes more of like a sideways S or a very stretched out S. Because I have arrows going left and right forever, my domain is all real numbers. I have one pointing up, one pointing down, so my range is all real numbers. It's going to be very similar to a cubic graph, just turned sideways or reflected over the y equals x line. Very similar in that, especially with the behaviors of it. So my point of inflection is h comma k, so in this case 0, 0. My end behavior is as I go to the left, my graph goes down forever, so negative infinity to negative infinity, and then as I go to the right, my graph goes up forever, so we're always doing that. So we're always increasing and we're never decreasing on these. Yeah, we're not. That's what's gonna happen. Trying to think of examples, but it doesn't really come to mind. All right, transformations, pretty much the same. We've already gone over AHK. My point of inflection is H comma K. And we've actually already gone over the reflected, the x-axis, stretch, and compression. I do believe if you actually have the physical notes, there is the filling in the blanks actually complete this as the same as the square roots. And I did leave off the HK information. But again, we just went over that, so I'm not as concerned that you should not be able to fill that out. You should be able to fill that out on your own. So go ahead, describe the transformations. Again, very similar to what we did earlier. So I want you to go ahead, pause the video and give these 4 problems a try. All right, let's go ahead and take a look at number 1. Number 1, I have a k value, so this is going to go up 9. We're going to jump to number 3. A is -1. H is -4. K is -7. Do remember, and I didn't specify it earlier, that on the inside, it is opposite of what you see. So this would be a vertical reflection over the x-axis. It would be left 4 units and down 7. On number 2, we have a vertical stretch by a factor of 5. And we have it moving to the right 2 units. On number 4, we have a vertical compression by a factor of 3/4. It moves to the right 6 units. And it goes up 1. And as always, pause if needed. So go ahead and see if you're able to answer or write the function for this problem. All right, let's check your work. So we have a parent function that is stretched by a factor of 3. So A equals 3. Translated, so the inflection point is -2, 3, so my H comma K. Write an equation that represents this situation or this new function. So we're just going to plug it in. So we have f of x equals 3 for a. I just realized this is missing a cubic here, so I need to fix that before we get to class. Cubic root of, curious now to know if, and I do see I missed it on the previous slide as well, so that I do need to fix that. That I will fix for the class. Cubic root, and then x minus, so minus minus gets me +2, and on the outside +3. So I do need to fix that. I didn't notice that until it's too late. Oh well. Moving on, we're gonna head and graph. So we're gonna take a look at number 6, and then you guys are gonna do the other 3 problems. So number 6, A. All right, there we go. A equals 1, H equals -3, K equals 2. So my inflection point is -3, 2. Now there's a couple things that are a lot easier to do on these, such as I already know my domain and range on all these are going to be all real numbers. I can do my inflection point. I'm going to have a -infinity and an infinity. And you can actually tell this based on your leading coefficient that we've spoken about. A is my leading coefficient. But we're gonna move up, we're gonna show you what we have on here. So I'm gonna go over left 3, up 2. So I'm gonna go up 1, down 1, and so from my point of inflection, I'm gonna go over 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go up 2 because the cubic root of 8 is 2. 1, 2. And if I could, I would also do that at the end. How close can I get, though? Is 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be like right here. I'm not, and I'm at the board for those that have seen the classroom. No, I'm graphing that pretty high. It's close enough. So let's see, as it goes to the left, it goes to -infinity. As we go to the right, it goes up. My leading coefficient is positive. I'm going up and to the right, so it's always increasing, never decreasing. All right, so go ahead and try 7, 8, 9. All right, let's go ahead and check your number 7. So A is -2, H is 0, K is -1, so 0, -1. Real numbers, all real numbers. 0, -1. -infinity, infinity. So let's take a look. So 0, -1, so I went down 1. I would go over 1 and up 1, and then we multiply that by -2, so I'm actually going to go down 2 from there. And if that's the nice thing is, I would say those first 3 points are going to be like a mirror image of each other. So if I go over 8, and actually that's all I'm going to be able to draw in this graph. So on my table, like x, y, y's, I do have 0. Well, not 0. Yeah, 0. 1, -1. I would need -8 and 8. So this is going to be a positive. I don't know, I'll be able to. 2 times -2 is +4. This is going to be 2. -1. Oh, I'm actually off by on these. So this is -3. Or -1, -5. So this is going to be 1. Two, 4, -1, so 3. All right, so 1, 2, 3, 4, 5, 6. I'm gonna go down 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Up 4. 1, 1, 2, 3, 4. So here's what my graph looks like. So I can see on my end behavior, as we go to the left, it goes to positive infinity. As we go to the right, it goes to negative infinity. It is never increasing. My slope is negative at all times. Moving on, I did want you to try 8 and 9. If you have the handout, we can go ahead and go over it. If you don't, please pause it, give it a try first. So for number 8, A is 1/2, H is -1, K is -5. So -1, -5. 1, 2, 3, 4, 5. So if I went over 1, I'd go up 1, but I'm only going to go up a half. So if I go over 8, 1, 2, 3, 4, 5, 6, 7, 8, I'm going to only go up 1 because I'm going to go half the rate. 1, 2, 3, 4, 5, 6, 7, 8. It's going to look about like that, just not scratchy. So again, domain and range, all real numbers. It's always increasing, so all real numbers. And A, point of inflection is -1, -5. As we go to the left, the graph goes down forever. As we go to the right, the graph goes up forever. Moving on to number 9, A is -1, H is 4, K is 3. So 4, 3. 4, 3. Up, oh, negative, so it's gonna be inverted. Up 1, down. I definitely can't go over 8. 1, 2, 3, 4, 5, 6, 7, 8. Up 2, 1, 2. I know I can't reach it to the cubic to 3, so we're just gonna go with that. All real numbers, all real numbers. 4, 3. As we go left, it goes up. As we go right, it goes down. It is never increasing, but it's always decreasing. Pause as needed, of course. And that actually is the end of the notes. So it's actually a pretty quick one, nothing too crazy. For those that have the handout, I do want you to go ahead and try doing that DOL and checking it with me in class. So you can go ahead and try that. But other than that, that is pretty much everything, and I will see you guys next time.